All right, so let's start with chapter 6. And one of the questions that you guys had was write the polynomial in standard form. And, oh, this is tough. Classify, do you guys remember classifying by degree and number of terms?
Sort of.
Okay, so this is something you probably want to put on your note card, just because it's easy to forget. Oh, you can't see this. Silly. Goodness. All right. Probably because I don't have it plugged in. All right. There we go. Okay. Change source. There we go. Okay, so if you are given something like 4x times quantity x minus 5 times quantity x plus 6, do you guys remember what you would do with that? Distribute what? You could do it that way. Multiplication, you can actually multiply in any order. So you could FOIL this first and then distribute, or you could distribute and then FOIL. Either one. So we'll distribute this guy, and that would become, I gotta change my color. I don't know what I'm doing with my pens. Let's see. Okay, so 4x squared minus 20x. Here's the tricky part. Because we haven't multiplied this one yet, we've got to keep it in parentheses because it's just not simplified. Then what do we do to simplify this out? Paige, do you know? Like something starts with an F, ends with a P. Ah, close. FOIL, good. So 4x squared times x, what would that become? Oh, there's a better pen. Good, 4x cubed. Man, I'm so bad with numbers. Okay, 4x cubed. Outside. What's 4x squared times? Good, 24x squared. What's the inside? Good. And what's the last side thing? Nice. Okay, any like terms I can combine? Middle two. So I have 4x cubed plus 4x squared minus 120x. Now this is standard form. Standard form. Here's something that's not in standard form. If I gave you something like, or if we ended with something like negative 20x plus 4x cubed plus 4x squared. Why is that not standard form? Yeah, it's not in order. It's got to be in descending order. So like if you didn't remember that, you'd be like, oh, standard form, degrees have to go high to low. And then now let's name it because it says classify. So here's what I always told my class with classify. I said just like you have a first name and a last name, all polynomials have first names and last names. First name is given to you by the highest degree. Last name is by how many terms you have. So this has a highest degree of 3. So what would be the first name? Cubic, good. What would be the last name? Yeah, you guys got that. Trinomial. Now, do you remember how to name all of them? Like what if it has, let's just do examples. Let's say that I give you the number 5. What would that be? Would be its first name. It's a constant. If you have x to the 0 power, that's just a constant. What's any number to the 0 power equal to? 1. So that would be maybe something to put on your note card. X, anything to the 0 power is equal to 1. So if you have x to the 0, that's why I could add in an x to the 0 because it's the same as 5 times 1. So that's a constant, and then what would the last name be? This one's last name was trinomial because it had 3 terms. This one has 1 term. Monomial, good. So that's a constant monomial. What if I gave you 5x plus 2? The highest degree is 1 now. Think about graphing 5x plus 2. What shape would it make? Like, think about it like this. Y equals 5x plus 2. Would it make a parabola? No, it would make it'd be a line because it's mx plus b. So it would be a linear. And then how many terms does it have? 2, so it would be a binomial. And then what if you're given 5x squared plus 3x plus 2? Do you remember what the squared term's called? It's a quadratic. Quadratic. And then it's got 3 terms, so how many? What would it be? Trinomial, good. And then last but not least, if you have, oh no, there's 2 other, I think that would make you memorize. What if you have like 5x to the 4th plus 2? You guys remember what this one's called? This is my favorite word.
Oh.
Close. That's a 5 power, power 5. Power 4, it's a quartic. Quartic. It's just fun to say. I mean, try it. It's a quartic. It like rolls off the tongue. Quartic. And then how many terms does it have? It's just fun to say. So it's a binomial. And then like an x to the 5th plus x to the 4th plus x to the 3rd plus x squared plus x. What do we call this guy? Quintic. It's kind of fun to say, not as fun. Quintic, and then it's got 1, 2, 3, 4, 5 terms. Yeah, just a polynomial of 5 terms. Okay, so that was like your intro lesson at the beginning of this semester. It was just how are we going to name all these guys we're working with? So I'm almost certain they will have a final question that says, name this, simplify and name it. So if you don't remember, I'd write that on your note card. Yes. Oh, so many good things in chapter 6. Okay. Another thing that we looked at was, or that you looked at, do you guys remember how to solve an equation by graphing? So like if you're given something like negative x cubed minus 3x minus 2 equals 0. So I know that I'm going to graph this. We're going to replace the 0 with a y so we can put it in on our calculator. But because we placed 0 with y, we're going to be looking for where does y equal 0. So where on the, oh, that's not the y-axis. That's the x, that's the y. But where on this would y always equal 0? Like if I, at what points does y always equal 0? Well, let's think about the y-axis. What point is this? 0. What point is this? 1, 2, goes up and up, right? And down here's negative 1. So at what point is y going to always equal 0? This axis. So our solutions when we're solving by graphing is they're always going to be on this axis. They're called your x-intercepts. They're also called your zeros. They're also called your roots I don't know why we have so many names for them. We're just weird. But yeah, all mean the exact same thing. And so I would plug this into my calculator. Negative x cubed minus 3x minus 2 equals y. And then, do you guys remember what you would press on your calculator? I gotta go get my calculator. He'd let you do that is if you press second trace 0, when it says solve by graphing, that's gonna be your method of action. Second trace 0. Okay, still in chapter 6. If it asks you, oh, gotta love these, write a polynomial in standard form with these zeros. And here we're giving a 0 at like 2, 3, and 5. I wish I had a bigger thing. Be bigger. Do you guys remember what to do with this? Yeah, x minus 2. Then what? Perfect. Yep. Awesome. Because if those are your zeros, those are like zeros, they're kind of like your restrictions if they're in the denominator. So yeah, you're kind of looking for where did they come from. Mary, do you remember that? Okay, I wanna take you back to something like this. What if I gave you x minus 2, x minus 3, x minus 5 equals 0? And I said solve, find the 0 values. Like what if I just said solve? What would you do? Set them all equal to 0 and solve, right? So you get x equals 2, you get x equals 3, and you get x equals 5. So what we're doing is we're just going backwards. We're saying if you have this as 3, put it back to where it came from. Does that help? See that? Okay. So once we have it here, it says put it into standard form. So what does that mean? That's where we need like all the degrees lined up, like top to bottom. So how are we going to line these guys up? Foil. We need to foil them first to simplify it out. So we're going to foil these two first, but then keep them in parentheses. So we have first times first would give us x squared. Outside would give us negative 3x. Inside would give us negative 2x. Last would give us positive 6. And then can I combine any like terms there? Yep. So I'd have x squared minus 5x plus 6. And then what do I do with this guy, this x minus 5? It's kind of like FOIL. So when you FOIL, you're multiplying everything by everything. So what we're going to do with this guy is we're going to multiply everything by the x and then everything by the negative 5. So if I multiply everything by the x, I would have x cubed minus 5x squared plus 6x. And then when I multiply everything by the negative 5, I'm going to do everything, I would have negative 5x squared. What's negative 5 times negative 5x? 25x. And then what's negative 5 times 6? Negative 30. Are there any like terms I can combine? Yeah. The x squared's negative 5x squared plus negative 5x squared. What does that add up to? Good. So I have x cubed minus 10x squared. Any other like terms I can combine? 6x and the 2x? Yep, so what would that add up to be? 8x, good. And then what do I end with? Okay. And if they took that one step further and said classify it, what would this be? Close. Cubic of how many terms? Do they tell you that to say polynomial of how many terms? They just say polynomial? Okay, that's good. Yeah, it's just sometimes they say polynomial of 4 terms. Yeah, good. Is this stuff, yeah, chapter 6, what you guys covered? You just remember this stuff, you think? It was a while ago. Okay, what if they give you something like this, and they say solve, and you have x cubed minus 10x squared plus 16x equals 0. Good. X squared minus 10x plus 16. Factor. Mary, I miss your voice. What could we do? Or what would do that factor to be? Yep. X and oh yeah, bring the x down. Minus minus, good. Same as the middle term. 8 and 2. Nice. So these are your zeros. So if they gave it to you, like here's your 0, here's your 0, here's your 0, that's why going back the other problem makes sense, because you would go back the other way. Good, good, good. Okay, do you guys remember long division? Or synthetic division? Do you guys remember doing that stuff?
Yeah.
Kind of.
Yeah.
Okay, let's do one. Divide using long division. If we have 3x cubed plus 12x squared plus 12x plus 48, and we divide it by 3x plus 12. Do you remember how to start this one? Divide what? Okay, how do you divide normally? X squared. Oh, you're saying, but do you remember we gotta like multiply it back through? But you started in a good spot. You said what times 3x would give me 3x cubed? And you're right, it was x squared. But then we've got to distribute it back through. So we have x squared times 3x would give us 3x cubed. And x squared times 12 gives us 12x squared. And then do you guys remember what we do in the process of long division? Subtract, right? The problem is we have 2 terms. So we've got to subtract both of them. Big key idea in algebra is if it's got a plus sign next to it, it's attached. You got to treat it as like one whole group. So if you do something to the one, you got to do it to the other. And you can't separate them. Okay, so then 3x cubed minus 3x cubed, that cancels. And then what's 12x squared minus 12x squared? 0. So we bring down the 12x. And then the process really just starts over. You ask what times 3x equals 12x? 4. And then we do what with the 4? Yep, distribute. Distribute this guy to both of these. So we have 12x, and then distribute the 4 times 12 plus 48. So I guess I should have brought down this guy too. And now what do I do? Subtract, good. Just using colors all over the place. Subtract, subtract. And then what's 12x minus 12x? 0. And then what's 48 minus 48? 0. So that's our remainder. So our answer is x squared plus 4 with a remainder of 0. Yeah, did that come back to you guys? Do you guys remember synthetic division? It looks like if I have 2x cubed minus 11x squared plus 2x plus 15, and I divide that by x plus 1, what would I do to do synthetic division? Yeah, a line. What do you put in a line? Yeah, the 2, the negative 11, the 2, and the 15. So we put those in a line, exactly like you said.
Yeah. If it's like, say you went, like, you went from 4 to 2, you would get a 0. Like.
Yes, you're right. You're right. If you're missing any terms, you need a 0. Exactly right. Even if you're missing this guy on the end, the constant. And then what do we do? So this like is our lineup. We're going to work with these guys. What goes in the little box that we're going to be constantly multiplying by? Yes, it's the 0 value. So it's negative 1. Mary, do you remember the next step? So you bring down the 2. Good. Negative 1 times 2 gives us negative 2. Close. You add. Add straight down. So negative 11 plus negative 2 is negative 13. And then it continues. Negative 1 times negative 13 is 13. And then add 2 plus 13 is 15. Negative 1 times 15 is negative 15. And then you add. So your remainder is 0. Now, what do I do with these guys? Where did this lineup come from? Yeah, with the x's, right? So I got to put them back in with the x's. The only thing I have to think about is I took an x cubed and I divided it by an x. So what should I start with? What's x cubed divided by x? Yeah, x squared. And then you just trail downwards. So 2x cubed, or 2x squared minus 13x plus 15. Synthetic. Look at us reviewing chapter 6 in like 20 minutes. Use the rational root theorem. I don't think you guys learned that one. Do you remember anything about the rational root theorem? I think they took that out of the algebra too. And let's see. Ooh, I'm sure you had to solve one using the quadratic formula though. Let's see. Solve the equation. That one might have been factoring. X equals. How'd you guys know that so well? Yeah, but would he like do it every time you used it? And so you guys just got it. That's awesome. There's so many people have so much trouble with this. There was a guy, some crazy story I was told by a different math teacher. He said that if he could not get the quadratic formula right on his next math test, he was going to tattoo it to his body. And he got it wrong. But listen to this guy. He's not the sharpest tool in the box because he tattooed it to his back. You can't even see it. It's like, okay, I don't know. Well, that would be funny. That would be funny, actually. But yeah, he tattooed it to his back. Like, come on, dude. Think a little harder. I don't know. You got the quadratic. Taking a mirror. Like, okay. All right. So So we know how to do this, opposite of b, so what would b be?
That's 6.
6 plus or minus square root of, yep, negative 6 squared minus 4 times a times c all over 2 times a. So it'd be 6 plus or minus square root. What's negative 6 squared? 36. What's negative 4 times 10? Negative 40 all over 2. So that's 6 plus or minus square root of negative 4 over 2. Do you guys remember what to do if you have a square root of a negative?
It's an I.
There's an I. So you want to think of this as if it was the square root of 4 times the square root of negative 1. So what is I the same as? This guy, right? So this would actually turn into the square root of 4 times I. But what's the square root of 4 equal to? 2. So it actually turns into 2I. Did I do it wrong?
I would just say, if once you get to that point where it's just like one number, it
Uh-huh.
I thought that meant that it was factorable.
It would have, yes, that's right if it wasn't a negative.
Okay.
If it wasn't a negative. Yes, you're right. You're right. But because it's a negative, it's not factorable because we can't factor when you can, but not really with the imaginary numbers. Okay, is this guy simplified?
No.
What would we do? Okay, one thing to be careful with. Could I cancel it right here and say, sweet? No, why not? There's, well, not even the I. It's attached to the plus and minus sign. So that's really the issue. So we got to get it away from the plus and minus sign. So what I would do is imagine dividing it out. And then I have 3 plus or minus I divided by 2. And now it's separated by a time sign. You can always cancel when it's separated by a times, not when it's attached to a plus or a minus. So we cancel out the 2, and then our answer is 3 plus or minus I. Okay. Do you guys remember what I squared is equal to? Wait, because it's the square root of negative 1. Well, hold on, give me a second. I'm sometimes wrong. But I is equal to square root of negative 1, right? So what's the square root of negative 1 times the square root of negative 1?
Because doesn't it, if it's a square root times a square root, like you say, it just cancels, it's just like 6, right?
Exactly right.
5, 6.
So Ryan's thinking about what it means to be a square root. Square root 5 times square root 5 is 5. Square root 6 times square root 6 is 6. Square root 7 times square root 7 is 7. Square root 8 times square root 8 is 8. So square root negative 1 times square root negative 1 is negative 1. Put that on the note card. Okay. What'd you say?
Sometimes we only get the note card for a second.
Oh.
I'm sure it's like, if we have, what, 5 different ordered note cards, it's not gonna like.
Put away the 7. Put away the 8. Yeah, I doubt. I think. And I'm assuming you guys are going to get a study guide soon, too.
Yeah.
Which.
Well, I think we have a bunch of practice tests.
Oh, you do?
Yeah, like for each test.
Well, we should do some practice tests together. You guys are going to be a boss when you come into this final. It's just, you're totally going to just do awesome. Paige, can I see that test? See how you did?
I have one question.
Mm-hmm. Oh, I'm still recording this.